Okay. I hope you guys can hear me well now.
Yes.
Okay, so as I mentioned, there's been a change in the weekly plan. We're going to start with the chapter 14 lesson 2. I made a mistake in the weekly plan, saying that we're going to start in chapter 17 instead, but I will update it once we finish today's session, okay? So you guys learned in the previous lesson about the physical changes. Can someone remind me what is a physical change? What do you mean by a physical change? You can say the definition, you can give me an example. Everyone? Again, what is a physical change? Can someone remind me about this?
The change in shape.
Yes, it's like a change in the shape, a change that doesn't change the matter itself. Okay. So let me get the lesson for you guys. So again, in lesson 2, we learn about physical change and physical properties. You already learned physical change is like changing the shape of the matter itself, doesn't make a new matter, doesn't change it into a whole new thing. You also learn about melting point, and we said it's the temperature at which a substance or a matter melts or starts melting. And once we say point, melting point, boiling point, it means the temperature at which this matter melts or boils or freezes and stuff like that. One of the things you guys already learned about during the previous years is density. And we said density, it's like if we wanted to make it into small words, we'd say it's how heavy a matter is. Like is it gonna, sink in the water? Is it gonna float? This is like the simple, definition of the density. As you guys can see, you did actually this project before. I don't know if you guys remember this one or not, but I remember Tanahi doing it as a science project. Um, I think a couple of years ago.
I remember it.
Yes, when he brought some different liquids and he put them all
They're different in
together.
mass.
Yes, and we were like trying to do an experiment about the density, if you guys still remember that. So, in order to tell you the difference, you have here 3 cubes. Can you guys see the 3 cubes? Wood, copper, and aluminum. Can you see those?
Yes.
Yes. Which one do you think, guys, has more density? It's gonna sink in the water.
Copper.
Yes.
Copper. Copper.
Copper and
Wood. Wood.
yes. Do you think wood is gonna sink or it's gonna float?
Float.
Float. Yes, because it has less density. But you can see that all of them can take the same space, can take up the same space, which means that all the 3 cubes have the same volume, right? Do you remember what
Yes.
by volume?
The space that the matter takes.
Well done. Thank you so much. Yes. The amount space a matter takes up. Okay. So as you can see here, the 3 cubes have the same volume, but obviously, as you guys mentioned, some of them are heavier than others. So that means one of them has the greatest mass, others have less mass. Okay.
Okay.
Okay, everyone.
Okay.
Okay, so density is actually related to volume and mass, which means that if I wanted to calculate density, I would use volume and mass. And here, you can see that density is the measure of how closely packed an object's atoms are. Do you guys remember solid, liquid, and gases?
Yes.
Yes, we mentioned.
The three states of matter.
Yes, we mentioned before that atoms and solids are packed close together. That's why it's solid. It doesn't change its shape. Like it has a solid shape and and a definite volume. You guys remember this from previous years? We didn't talk about this year, but you already know it.
Okay.
Everyone, can you hear me?
Yes.
Yes.
Yeah.
Guys, I think it may be cutting a little bit, the internet connection. Guys, can you hear me now?
Yes. Yeah.
Okay. Okay, so as I mentioned, what we're talking about when we were talking about density, that solid substance have all their atoms close to each other. So that's actually density, because you guys remember gases? Did you guys remember
Yeah.
atoms were far away from each other? I think that was in lesson 1. You had this picture. Here it is. Okay, so this picture is showing you guys how atoms are packed in each state. Like in solids, you can see they are packed closely together. In liquids, they are a little bit far, and then in gases, they are way far from each other. So these are different diagrams of how atoms are packed in the different states. So how atoms are packed is actually the atoms, or I'm sorry, the matter's density. Okay, so when the atoms are closer, that means density is more. Okay. Okay, guys. So what's the density again? It's how heavy these things could be, how they sink in water, and the best example is having different liquids. As you guys can see, though, this you have different liquids here: oil, water, shampoo, and dish soap, antifreeze, and maple syrup. You can see that they are not mixing because of the difference in density. Okay. You can do this at home. You can bring water and some oil and try to mix them together. You will sense first that maybe they are mixing, but if you left the liquids to settle, you will then notice that oil is actually on top of the water.
Just listen, density.
Yes,
So it will get up.
yes, well done. Yes, because of its density, yes. Oil is actually lighter than water, so that's why it's going to be over the surface of the water, and water will be down, because heavy things always go down, if you guys remember this.
Yes.
Last but not least is mixtures and solutions. You guys already know this also from previous years. Can someone tell me what is a mixture?
When you put a lot of things together and make
Put things together, but you can still see everyone. Like, the fruit salad, for example. Fruit salad. Do you know fruit salad?
yes,
Yes, that's a mixture.
cutting.
You can see different fruits. When you mix, different solids together and stuff like that. So you guys already know the difference between mixture and solution. What is a solution? What do you guys think is a solution?
I don't know.
Okay, it's when you mix, it's like a new thing for you. It's when you mix two matters together, but those two matters will actually mix that you cannot differentiate between them. Like mixing,
Like salt and water.
yes, like mixing sugar with water. For example, salt with water. That solution cannot
Lemonade.
be once you mix sugar with water. Can you actually see the sugar, or can you differentiate between the sugar and water atoms?
Disappears. Disappears.
Kind of, yes. Okay. So I think everyone is here. I don't have anyone in the waiting room yet. We are only 17 today. Hope everyone is okay. Guys, you will see that there's been study sheets uploaded on the SMS. I hope you will check them. Okay. Solution could be also a mixture of gases. You know the tank we use in order to dive, the oxygen tank.
Yeah.
Yeah, we use this one to dive. If you guys tried this before.
Okay.
Did anyone try diving before?
I
No,
did.
but no, but I see it in most of
Yes, but you see.
television.
Oh, okay.
Me too.
Yes, I hope you guys will try it. It's a really fun experiment. I didn't try.
I went diving before.
I hope I can try, diving as soon as possible. But scuba diving or scuba divers with oxygen tanks, they have oxygen tanks. We call it oxygen tank, but it's not actually oxygen only. It contains different gases. It contains oxygen, other gases, and nitrogen. Can you guys see the circle here on the left?
Yes.
Represents the gases we find in the air as we breathe in air. So when they build oxygen tanks, they try to make it as similar as the gases we breathe in air. Okay. So can you differentiate between the gases in the tank?
No, they are all gas.
In the gases in the air we breathe? I mean, right now we're breathing oxygen, right? Can you actually differentiate between gases right now?
No.
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 Yes. Do we have Amr with us today?
Yes.
Oh, okay, Amr, I was checking if you're here. Okay, so Amr, can you differentiate between the gases you breathe?
No.
No, you're just breathing air, right? Then your body will
Yes.
do the job and get only oxygen and stuff like that. And that's why it's so dangerous to breathe in smoke or or polluted air, because we actually breathe in the air. Our bodies do not differentiate between the air as we breathe it in, just take a mixture of air. And then your body will take in only oxygen, but still carbon dioxide, for example, which is polluted gas, or can cause death in some cases, just came inside your body. So that's why pollution is not very it's not very good to breathe in smoke and stuff like that. Some people can get suffocated from smoke. Yeah. So again, that's what we mean. In this case, you cannot differentiate between the air or the gases. That means it's a solution. Okay. It could be a mixture of gases together. That's a solution. Here, you have some liquids mixing together, right?
Yes.
Right.
Yes.
Yes.
Yes, you can see the liquids. This is tea with milk.
Yes, I know it.
We all know this. It's actually a really famous drink here in Egypt. That's also an example of mixtures. Okay.
Okay.
Another example, do you know fizzy drinks? Fizzy drinks like Pepsi, Sprite, and stuff like that?
Yes.
Yes, yes.
When you drink those things, عارفين الستيم?
Yes.
Yes.
Actually gas. This is carbon dioxide, CO2. That's why it's not healthy to drink a lot of fizzy drinks, because they contain carbon dioxide in them. But that's a solution also, because you have two things in this liquid. You have the liquid, the ordinary liquid with sugar, and you have gases. So that's also a solution.
Solution.
Solution is a mixture. If we wanted to tell the definition, mixture is a combination. First, let's talk about mixture. Mixture is a combination of two or more substances, okay? But they are not permanently combined. That's very important. Like we can actually, separate them in some point. Okay, that's what we mean by a mixture. We can separate it in some point. So,
Miss, how could we separate liquid and gas? Like in
No.
Pepsi.
that's why
Not solution.
it's a mixture. It's a
Mixture, not solution.
Just listen to the difference first. Get the difference first, and you will, يعني the different in the session. I'm sorry, guys. Move to the first page. I'm sorry for that. Just give me one moment to get back to the page. Back to what we're saying, a mixture again is a mix between substances that are not permanently combined. Like you can differentiate between them, okay? But what's a solution? That's a different thing.
Solution.
Solution is a mixture also, but all parts are mixed evenly. Yani you cannot differentiate between them. You can't see the different parts.
They are mixed permanently.
Yes?
Mixed permanently.
Yes, they are mixed permanently. Let me show you something here. Okay. So for example,
Miss Batul,
picture.
what is heavier? Mixture of the solution.
It's up to what is a mixture made up of. You can't compare between mixture and solution without knowing what is it made up of. You have to know what's it made up of first. Okay? A mixture could be heavier, a solution could be heavier. It's up to what it's made up of. So for example, in this picture, you can see marbles. All of you know marbles, right?
Yes, Bill.
You can see marbles here with water. Can you guys see them?
Yes.
Yes.
Yes. So the marbles with water are not mixed evenly. I mean, you can see the marbles, you can see the water, you can actually separate them.
Yes.
Yes.
Right? Yes. But in solution, for example, here we have salt and water. Once you mix salt and water, as Tanahi mentioned, they will disappear, which means that they are mixed evenly. Okay? You can see the different parts. Okay?
Okay.
That's one of the examples. You can see the different parts. Another famous example, as I mentioned to you guys, for mixture is the fruit salad. You can see different fruits. You can know the different parts. But in solution, all the parts are mixed evenly. You cannot see the different parts. Okay?
Okay.
Yes. Here, for example, once you mix tea with milk,
Milk.
first you can see the difference, right? But then they will be mixed evenly, right?
Yes.
Yes. Do you guys get the difference?
Yes.
Type. Do you know the salad dressing, or we can say it's like عارفين التقلية, the one we add to curry,
Yes.
On what?
اللي هي التقلية اللي بنحطها في الكشري. Do you know it?
Yes, yes, yes.
Yes. You can see different parts in it. So that, what does that mean? Is it solution or a mixture?
Mixture.
Mixture, yes, well done. So once you can see the different parts, it's more to mixture than. So guys, these two lessons are really related. So that's why we're gonna walk into the third lesson, which is talking about chemical change, because it's really related to physical change. Yeah, you cannot learn about physical change without learning about chemical change also. But before that, would say we have different examples of physical change, other examples that we didn't learn about in the lesson. Cutting, shaping a paper, for example. Do you think it's a physical or chemical change?
Physical.
Physical, because we didn't change the paper itself. It's still paper, okay?
Yes.
Miss, like some breaking the chair. It's physical.
Breaking the chain. Breaking
Chair. Chair.
yes. A chair. I'm sure I heard it as a chain. Breaking a chair is, yes. Are you asking me or are you telling me an example?
Asking. Physical.
Yes, it's a physical. Did you change the wood? I mean, it's still made up of wood, right? يعني did it change the chair? Did it change from being made up of wood, for example? Did it change into liquid or water? Or is it
No.
No.
still a chair, but its shape changed because now it's broken? Like breaking glass, okay? When you break a glass of water, for example, it's still glass, but it's like now it's small pieces.
Small.
Yes, it didn't turn into a new matter. That's what we're gonna learn about today. It didn't change into a whole new matter. It's still the same matter. For example, crumping papers, here, like this picture, you guys can see. By the way, you can find this this study sheet on the SMS now. You know, having papers crumpled like this, this is like a physical or chemical change.
Physical.
Physical.
Well, paper,
Change only the shape.
pieces of paper. Also change the matter into different states like solid, liquid, and gas, as we mentioned. That's also
This
physical change. Yeah,
chemical.
what's a chemical?
No, physical.
No, this is physical because it's still water.
Yes, it's still water, but in different shapes. Like it could be in a gas shape or a solid shape or a liquid shape, but all of them are still H2O. So they didn't change into a whole new matter. Okay, that's a physical change. Then you guys learn about the different process which a matter can change, like melting, boiling. Remember that? When we melt plastic, for example, I want you guys to think. When we melt a piece of plastic, did it change? Or is it still plastic but in a liquid shape?
Still plastic, but in a liquid shape.
Still plastic but in a liquid shape. Well done. Is this Amr or Tanahi? Amr, okay, good. You guys have like similar voices. I'm sorry about that. Okay, and then you learn about sublime, which is a new word for you guys, and it means to change from solid directly into gas. You know, things will, for example, a piece of ice, once you get it out of from the freezer, it will change first into a liquid and then it will change into a gas with time. Yeah, if you left a glass of ice, just leave it around, okay, with pieces of ice. With time, the ice will turn first into liquid. And then if you left the glass of water for a couple of days, you will actually notice that the water is getting less and less. Why do you think the water is getting less?
Evaporating.
It's evaporating.
Rating, yes, well done. Okay, so that means liquid was first a solid and then it became a liquid and then it became a gas, obviously.
Yes.
But in some cases, solid can be directly a gas without being liquid, which is a famous example like yes, the dry ice. Do you know dry ice?
فتح المايك على.
Okay,
Sorry.
it's okay. It's okay. Do you guys know the dry ice, like the picture here?
Yes.
Yes. This dry ice is really famous because it doesn't turn into liquid. It actually changes directly into gas. So it changes from solid directly into gas. It's called sublime, which is a whole new word. You guys learning about also this term. So when I say melting, for example, melting, it's like when the substance turns from
Solid to liquid.
solid to liquid. Yes, well done. And when I say boiling, it means it's changing from
Liquid to gas.
liquid to gas. Okay. Freezing,
From liquid to solid.
liquid to solid. Yes, well done. So when I say sublime, that means it changes from solid directly into
Gas.
dry ice we're talking about. Okay. And then you guys learn about density, how close particles are packed together. That's what we mean by density. Okay. And we can actually measure density with mass and volume. Mass divided by volume can actually give you the density of an object. Like if you know its mass and if you know its volume, you can calculate density. Okay.
Miss,
Yes.
can liquid change to gas before, and it's not coming to solid? So it didn't come to solid, but changed to gas.
You mean liquid to gas or solid to gas?
Liquid to gas.
Liquid to gas. Yes, that's evaporation.
Ah, yes.
Water, it changes from liquid into gas.
Miss, solid to gas. Is it evaporation?
Gas solid
To gas,
without
yes.
being liquid.
Yes.
Yes, it's another process, but it's called deposition. Deposition, and you can have an example of it if you've been in a really cold places, really cold places. In the countries where it's snowing all the time. Sometimes the water vapor in the air can change directly into frost. Frost. Do you know frost? It's like ice, but a little bit smaller.
Yes.
This is actually
Yes.
because it's changed from gas into liquid. But this is another process called deposition. You're not learning about it in this book or in this year. But that's a really nice question. Thank you so much, Am. What's Tanahi again? Because you guys.
صراحة.
Okay, Tanahi, yes. Yes, a gas can be also a solid directly, but in this case, it's called deposition, not sublimation. So sublime is when solid into gas directly, and deposition is when gas into solid. Okay, then you guys learn about mixtures, and in mixtures again, the things are not permanently combined and it doesn't change its property. For example, here we have different vegetables. You can see the different vegetables in here, right? You can see carrots, you can see peas, uh, beans, stuff like that. You can see the different parts that making up a mixture. But a solution, it's when all the parts are mixed evenly. Again, the word evenly is important. It means you cannot see the different parts, like mixing salt with water and sugar with water and stuff like that. Last but not least, some other physical changes that you guys will learn about in the last page is like cutting, breaking. This is supposed to be breaking. I will fix it for you. Crushing things, bending metals, for example, melting, freezing, boiling, recycling stuff, recycling different things, or kneading a sweater using thread, painting. All of those are examples of physical change. Okay?
Because we change only the shape.
Yes, only change the shape, not the matter itself. Okay?
Okay.
Now let's talk about chemical change. And in a chemical change, as I mentioned before, physical and chemical are really related. So if you're learning it, you have to learn about things. Of course, here is telling you some safety precautions you need to take, and how some symbols mean in the science lab, toxic, harmful, stuff like that. But I need this right now. Okay, so here we have everyday reactions that we actually do every day without knowing that this is a chemical change. When we cook something, can you change it back to its previous shape?
No.
No, it's a irreversible process. You cannot get it back to its previous shape once you start cooking it. So cooking is actually a chemical change that we do literally every day because we cook every day, unless you get a food from a restaurant, but it's still cooked. So yeah, it's a chemical change. Sticking things together, burning, chemical change. Okay, making other materials, like changing a material from one type to another. Rusting. Do you know rusting? Rusting?
صدف.
To to to
Solid.
break something.
Yes.
To
صدف.
break
يصدف.
Yes, it's when the iron changes, like it becomes this browny layer over it. So that's what we call rusting. لما حاجة تصدي يعني, as Tanahi mentioned. Okay, and also having different living life process, breathing, eating and stuff like that. All of those are chemical changes actually. Okay, so there are some things that tell us this is a chemical change, like when we have a change in the color, when we have gas, like breathing, for example, you breathe in oxygen and you get carbon dioxide out, right? That's actually a chemical.
Yes.
Yes. When something becomes really hot, really cold, but that's not a single sign. You cannot say this thing got hot, so that means it's a chemical change. No, because I think boiling and a different process that can actually cause physical change can be hot and cold. It's signs, some signs. علامات على chemical change. If it gives out light, if it makes smell, you guys, if you went to some scientific college and you did some experiments has really bad smell. You will actually notice that when you go to college.
Yes.
Okay. So for example, here we have an example of, let me tell it here. Okay. So here is giving you examples. These, I'm sorry, 3 of these changes are chemical changes, but 1 is a physical change, which is the one that odd 1 out, which means we're going to take 1 out of them. One of them is not a physical change. Yes, Am, is not a chemical change. Yes, Am.
Melting ice.
Melting ice. Yes, so it's going to be D. Right, we're going to take D out. Yes, well done. Correct. Okay. Now he's here. Also, 3 of these changes are chemical changes, but also 1 is physical. So we need to take 1 out. So who's going to answer this question? Yani one of those is not a chemical change. It's actually a physical change. So let me see the people raising their hands here. Okay, we have Kinsey.
Hi.
Hi, Kinsey. How are you? So can you odd 1 out? Yani take 1 of those examples out, which means it's not a chemical change.
Okay, 3 of these changes are chemical changes, but 1 is physical change: burning candle, photosynthesis, iron rusting, and steam from kettle. D.
So it's gonna also be D, steam from a kettle, which means it's a water vapor, which is a physical change. It's still water, or it's still the liquid, but it changed it into a liquid shape. So yes, photosynthesis is a life process that plants do in order to make their food. And in this one, they take in carbon dioxide, sunlight, and water and change it into a whole new matter, which is sugar and oxygen. So in this case,
Miss,
the chemical change because it changed it into a whole new matter. Yes?
burning a candle, the candle could solidify again.
I can't hear you. Can you repeat your question, please?
A, burning the candle, right? The candle can solidify again. How did the chemical change?
Candle is not like melting a candle. There's a difference. Burning a candle, he means the burning itself, the burning process. It's not the melting. So there's a difference here. Okay? If we said melting a candle, that would make a physical change because now we're only changing its shape. But burning is actually a chemical change. So it's going to be D as we mentioned. Okay. So here we have other examples. Can you guys see them?
Yes.
Yes, we have digestion, respiration, breathing in, dissolving sugar, or burning magnesium. Which of those is not a chemical change? It's actually a physical change. We have Tanahi. He raised his hand.
Okay. Digestion, dissolving sugar, burning magnesium, respiration. What is respiration?
Breathing. You know, like respiratory system. Breathing in. Breathe in oxygen and give off carbon dioxide.
And what is digestion?
Breaking
The
down
digest-
food. Learn about this in term 1. How can you now remember those words? Breaking down the food and changing it into the nutrients you need.
B.
B is also a respiration, which means changing oxygen into carbon dioxide.
Into carbon dioxide.
Matter.
It will be oxygen again because the plant will make it oxygen again.
It will be what, sweetie?
Oxygen again because the plant will breathe the carbon dioxide and give us oxygen.
No. Don't talk about what happens when it gets out from your body. We're talking about respiration only. And respiration means taking in oxygen and giving off carbon dioxide. For the carbon dioxide to change into oxygen by plants, that's another thing. It's another process. But now what happened is that during respiration, it's that it changed oxygen into carbon dioxide, which it changes into a new matter. So it's still a chemical change. Burning,
Digestion.
always a chemical change, because you cannot bring things back once they are burnt and they actually change into a new matter.
It's digestion. Digestion.
Yes, Tana?
Because dissolving sugar, you can't. Digestion. Because dissolving sugar, you can't get the sugar out of the water.
Yeah, but did it change? Once you dissolve the sugar in the water, every atom is still keeping itself. And still water is still H2O and sugar is still sugar, but they are only mixed. It's mixture.
Okay, so let's see.
You can't separate them in one point. So it's gonna be C, yes.
C.
Yes. Thank you so much, Tanah. Okay, guys, we have 1 minute left. Okay, I will try to show you different examples. Here, for example, we have another example like rusting is also a chemical change. You guys already know this. Burning.
Miss, you didn't take the attendance.
Yes.
You didn't take the attendance.
I will take a screenshot of your names. Combustibility or burning is a chemical change. It's a big word. We'll learn about it later, inshallah, in the next session. So combustibility is burning. It's a chemical change. Or fermentation, which is like cooking and changing things in different manner. Ripened fruit. Once the fruit becomes ripe, that's another example of a chemical change. So next time, we'll learn more about chemical change. Again, guys, I will update the weekly plan because now we need to move on chapter 14, lesson 3. So I hope you will check the new weekly plan on the SMS. Okay?
Okay.
Do you have any questions before leaving?
No. No, thank you.
You're most welcome. Thank you guys for